In exercise number 1, we are given a table of DH parameters and we are asked to find the configuration of the robot by drawing. And this is an exercise that is very easy to get wrong. So let's start. The first thing we want to do is to fill in all that they give us into the table. And now let's get drawing. Start with the axis 1, and we know that since all of the parameters are 0, the axis 1 and 0 is perfectly aligned. And now, using the right-hand rule, we can find the x1, or actually x1 and x0 axis. Could look like this. X0 actually. Now let's move to axis number 2, and the first thing we will notice is that this parameter alpha 1 is the rotation between two z-axes. So from z0 to from z1 to z2, we rotated an angle of 90 degrees around the axis x1. So that looks like this, because this is found using the right-hand rule. And so we know that the direction of the z-axis is gonna look like this. This is z2. But we have to be cautious, because if z2 is here, or here, or here, it also results in a 90 degrees angle. So to know which of these three is the correct one, we have to look at the parameter A, and it is 0, which means that the distance between two z-axes is 0, and the only way for that to be is for the z-axis to be this line. Now the next step is to find the coordinate origin. And to do that, we have to look at the parameter d. And it says that the distance between x1 and x2 is 2l. And that means, since x1 is right there and x2 is found by moving along y1, a distance of 2l, we know that x1 has to be here. Now, even when we know it's here, it could be like this or like this. So we have to look at the parameter theta I. And theta I in this case is 0. So we know that theta I is the rotation angle between the two x-axes, and since it's 0, x2 and x1 should be perfectly aligned. And that means this is our x2. And this is our z2. And using the right hand rule, we can deduce that y2 is this direction. Okay, now let's move to the third axis, but before that we have to draw in the axis as well. So I forgot to draw in the axis rotation. So for 0, that would be along the axis z0, and it rotates like this. And for axis number 2, it's like this, and this is not a rotational axis because of the parameter di. That's actually the free parameter. So this one we actually know it's actually a translational axis, or it's also called the prismatic axis or prismatic joint. And this one is 2L is equal to Q2. Let's come to the third one. So the third one, we know that the z-axis is rotated an angle of negative pi over 2 relative to the z-axis of frame 2. So negative pi over 2, and we have to remember that it's the right hand rule of rotation around x2. So negative pi over 2, that would give us the z2 direction like this. But to know where it is, we still have to be cautious, because it could be like this, and it would also be pi over 2 or negative pi over 2. So to determine its position, you have to look at the a parameter right here, which is 0, which means that the distance between the two z-axes is 0. And the only way for that to be is that the z2 axis has to go from here. And we know that it points up, but we don't know where the coordinate origin yet. And for that, we have to look at D3, right? And D3 is L, which means that the distance between x2 and x3 is L. Now that puts us right here, right? Because this is the axis x2, which is right here. I accidentally deleted that. The x2 is right here. So distance of L away from x2 would be like so. And again, we have to look at the angle. And here, the angle, theta I, which is also 0, tells us that the axis x2 and x3 is perfectly aligned. So we know that perfectly alignment means that x3 is here. And now it becomes easy, because now we know that y3 is this way, according to the right hand rule. Now we still have one last task, and that is to find this vector. And this is very simple. This reads that the two center point expressed in the coordinate system R3 is 0, 0, negative L, 0. And that means that we just move into negative y direction a distance of L. And this would be our two center point. Now, there is still I forgot to draw in the rotation axis of the third one, which is the rotation axis and not the translation axis. So this would be Q3. And this is how you solve this task. So the procedure to solve this kind of task would be first get the direction of z axis with alpha, and the index we don't really care. Why? Because just have to remember that whatever this alpha is, it is telling us how to get from the previous step to this step. So from rotating from the previous one to the current one around the previous x-axis. So the dh parameter always tells us, when we know our current position, how to get to the next joint. So it's always relative to the previous joint. When it rotates relative to the previous joint. When it translates, it also translates relative to the previous joint. Okay, so returning to this, secondly, get the position of the axis with A. The third step is get the coordinate origin with D, and that is because the D is the distance between the two x-axes, and the intersection point of the x and z axis is where your coordinate origin is. And fourth one is get the direction of x with theta. And to be honest, this is how I do it from 1, 2, 3, 4, but any step of this, no matter which order you do it in, it's still gonna result in the same thing. Of course, we have the fifth step, which is use right-hand rule to get the y-axis.